Thank you, Hans, and welcome everyone. As Hans said, I'm working at Linköping University since 2003, primarily with improving energy efficiency in industrial SMEs. And it's my great pleasure to have this short webinar with you today. The the content will be that I mention something about energy end use and the potential that we have in SMEs. And then we go through the barriers. I will just briefly take the theoretical barriers today. It's a quite extensive subject, but I will try and give you a brief introduction about the theories behind that. And then we go into energy management in SMEs, and then we end with we'll make a landing with SME energy policy programs. So here we go. For a country, it's of great importance to work proactively with improved energy efficiency. And in this room, we probably all are on the same page, so to speak, in this regard. But I would just like to emphasize the importance for a country to work proactively with SMEs and improved sustainability. We have a future where there will be lack of resources or scarcity of resources, and companies who are proactive in this regard and companies who are gaining support, governmental support in terms of policy programs, will be beneficial in the future. Here are some key figures for SMEs in a few countries. As we see in Japan, it contains 46% of the industrial energy use, while in Spain it's only 27%, but still it's not that small share. If we go on the second column, we see that the SME share in Japan of CO2 emissions is 11%, and in Sweden about 25%, and also in Belgium 11%. And if we go then on the economic output, we see that in Japan it's almost half of the manufacturing shipment in 2006. And in Sweden it's 37%, and in Belgium 40%. So having said that, the one major key point when it comes to industrial SMEs is not only the energy saving potential, but the importance for the economy that these companies are operating well, where energy is one important factor. So there is a great energy efficiency potential in industrial SMEs. It's even greater or larger than for energy intensive industry, even though the energy intensive industry in most countries have a larger energy end use. So, but the potential in SMEs is higher. That's what research shows. I have not provided you with a figure here. We know that the European Commission states 25% in their action plan, and I have papers written, colleagues of mine have papers written in Sweden and internationally about various figures, but I will just say that it is high, and then we can I will not provide more details about that. But the potential is high, but the implementation of energy efficiency in industrial SMEs is not as high. So there is a discrepancy, a difference between the potential and the level of implementation or the deployment level. And this is something that is often missed in general, not only in regard to SMEs, that we often engineers like me, we speak about potentials and then we assume that we can reach the whole potential, but research doesn't say that we can reach the whole potential. Normally in energy audit programs for SMEs, we can reach 50 to 60% of the potential outlined from the audit reports. But anyhow, so there is a difference between the optimum level of energy efficiency and the level we have today, and this is what is called the energy efficiency gap. And the gap is something that is explained by the existence of various barriers to energy efficiency. And I'm not a social scientist, even though I worked some with social scientists, but I just have to say no one of us have seen a barrier. So it's a social construction about how to explain the energy efficiency gap. And the explanation of different of the energy efficiency gap and barriers is a quite extensively researched subject. Probably, I would say, York started in 1978, so we have more than 3 decades of research in this regard. And when we speak about barriers, we differentiate between market barriers and market failures. And a market barrier can refer to any factor that explains why investments in energy efficient technologies are not undertaken. While market failures refers to those market barriers which are so-called what should I say? They violate the fundamentals of energy of economic theory, and I will just briefly show you the key 4 of those market failures. And in case we have a market failure on the market, and the intervention, for example, an energy audit program from a country, passes a cost-benefit test, it can justify an intervention. So I will give you some theoretical barriers here, and this I owe great thanks here to Steve Sorrell and his co-authors in his report from 2000, where they put together this summary of barriers. And we start with the so-called market failures. And as I stated, market failures are a result of violations of the axioms, the fundamentals of economic theory. And one of the axioms is that we have perfect information on the market. So if we have lack of information, that is of course one typical barrier, that SMEs, they don't know about what measures to undertake. And so lack of information is a very, very common mentioned barrier. Then we have split incentives, which I normally exemplify that by stating that if you are the CEO of a company and I'm the division manager, I will not care about your energy management program if the cost, the allocation of cost, energy cost for my division is done on square meter or per employee and not based on sub-metering. Then the incentive for me to put money in my budget to invest in energy efficient technologies is not that high. So that's an example of split incentives. And then we have adverse selection, which basically means that there is an asymmetry, a difference between the supplier and his or her knowledge about and information about the product than what I have as a consumer. And the fact that energy efficient technologies are not often bought like we buy milk in the store, which means a few times every week. For example, a ventilation system, we invest in that maybe 25 years, we make a new investment. And this means that we tend to make these decisions on visible characteristics, like, for example, if I'm a bit joking a bit, that we choose a gray ventilation system or a black one, because that looks good, and we don't take care of the energy performance. Then we have a principal-agent relationship, and if you allow me to make a little example again of you and me, this could mean, for example, that if you're the owner of a company and you don't really trust this CEO, which is me then, because I put too much money on company partying and so on, you put in strict monitoring rules and say that you're not allowed to take any investment above 1 year payoff. And this, of course, inhibits investments in energy efficient technologies. So those are the 4 market failure barriers in relation to improved energy efficiency. If we go to the market, non-market related barriers, we have heterogeneity, which means that when we do a potential study of a technology, for example, LED lighting, we tend to miss that the application for this technology is not applicable in all cases. So this means that sometimes the potential level that we state is based on a top-down calculation is not as high in reality. Then we have hidden cost, which means that when we undertake an investment, there are costs allocated to the investment, which are not only the investment cost. It could be search costs for information, analysis of information, procurement, etc. And those costs can be quite high, and this is also a factor that can inhibit investments in energy-efficient technologies. Then we have access to capital, a primary barrier for industrial SMEs. And not much to say about that. If you don't have money, it's hard to invest. But the last barrier, risk, is states that sometimes the lack of access to capital can be self-imposed, because industrial SMEs tend to be more risk averse than other larger companies. And also sometimes when it comes to energy service and ESCOs that make an agreement with an industrial SME, is that it can sometimes, we have seen in research, be difficult for the SME to be credible towards the bank, because it's not the multinationals that come and ask for money. So the bank sometimes give a neglect of allowing for the ESCO because of risk. This is also a barrier for energy efficiency. If you go into the barriers that emanate from behavioral science, even though the first one, boundary rationality, would probably not like himself to be categorized there. It's Herbert Simmons that received a Nobel Prize for mathematically showing this. But boundary rationality basically means that we don't make rational decisions based on perfect information, etc. But we make those decisions based on the rule of thumb. And then we have form of information. And if I would have stood before you in front of you right now, invisible, I would have said that this way of providing information is better than receiving an email. And I think I can say that also by just having a voice to you, that this type of information, that is, research shows that information needs to be specific and vivid and simple and also personalized in order to have it uptaken. So even though information is available for industrial SMEs, it's difficult for them to find it. So, and that is also a barrier for energy efficiency. And then we have credibility and trust. And this basically means that if you don't really trust me and the way I provide you information, it's very less likely that you will undertake an investment that I propose to you. For example, if I provide to you an energy audit. And then we have inertia from social science, stating that we are often, as individuals, quite slow in adopting change. So I sometimes exemplify this by companies who are implementing lean, the Toyota model for management. That normally takes 3 or 4 years before the organization is getting used to it. So we are quite slow, actually, as individuals to adapt to change, etc. And this is also a barrier we've seen in research. And then we have values, which if we don't have values for energy efficiency, for environment, it can inhibit investments. And I have one example of that from my early years of PhD, where I was conducting interviews towards industrial SMEs, and I asked them, came to an environmental manager, and I asked, so how do you work with improved energy efficiency in your company? And he said, hey, in this company we're not environmental weirdos, we're doing drag racing on our spare time. And by saying that, of course, he stated that he's not so interested in improving energy efficiency and environment anyways. He felt that his position as an environmental manager was not like the highest ranked in the organization. So in that company, energy efficiency was downgraded because of values. Then we have power, and if I violate myself a little bit, we can say that in general, energy efficiency is not the top priority, and the person that the issue is put on, for example, maintenance manager, it's not often sitting in the top level of the company. And then we have culture. If I summarize a little bit, we can call culture the sum of the values of each individual in a company. And the same holds here as for values, that if we can create a value in in a group, that we can make a change. It's possible to make a change, and we work together with improved energy efficiency. This will create the momentum that leads to success. But if this is not there, this also can inhibit investments in energy efficiency. So that was the theoretical barriers for improved energy efficiency. And now if we go, I could provide with you results from various papers from international colleagues and of ours here in Sweden. But I just summarize with this, that research shows that barriers differs a lot. And it depends on sector and type of production and size of the company and type of ownership. So I have still not seen the paper, and it can be because of lack of knowledge from me, but I've still not seen the paper where we summarize that these are the key barriers, period, for industrial SMEs. They tend to differ. And before we leave the barrier part of the webinar, I just want to mention something about energy efficiency in core business. And from a Swedish perspective, the core business notion came into industry about 50 years ago. What not so many know is that the core business focus is actually based on a research paper by two American researchers back in 1991, stating that if we are to improve and succeed in our company, we need to focus on our core business. And in relation to core business, improved energy efficiency in a manufacturing industrial SME can never per definition be core business, because it does not create any revenue. And this doesn't mean that we can put it up on top of the agenda, but we have seen that this strong emphasis on core business can sometimes harm the improved energy efficiency of a company, because the parts that are not core business can be outsourced. And if you outsource one key person that knows the technical energy system, we have a problem with improving energy efficiency. Not on today's topic primarily, but when we look on energy intensity, we tend to measure that on the energy use in relation to GDP. And if we look on the total energy use, we can exemplify this by a simple equation, and don't be shocked by the numbers and so forth. It basically means that the industrial energy use is the production processes energy use per product, and then we have a term S0, which means all the support processes. And when looking into this type of categorization, the production process are the processes that are needed to produce the products, and then we have the support process which supports the process, the production process. And this categorization can look like this, where we have, if you look on the support process side, a number of defined support processes, and then we have theoretically tried and make a list of typical production processes, but I don't want to give emphasis on this, but just that we can categorize the various types of processes in a company, and that the energy use of a company is both production processes and support processes. And if we look here, we have an engineering company, an SME, and if you look on the very top part of the figure, we see that metal cutting, CNC machines, is about 22% of the total energy use. And then we have the phosphate finishing of 1%. So in this company, the total annual energy use is primarily consisting of support processes. If we look on a quite energy-intensive SME here, foundry, we can see that about 50% of the annual energy use is from the support process, and about 50% are from the production process. And even though not on the topic for today, we can see here an energy-intensive large pulp mill, chemical pulp mill. And we have the evaporator, we have the drying, we have the digester, and then we have others. And others is the only category in this from this paper where we have the support process. So we can say by this that the support process are at the very maximum 15% of the energy use in this company. So, having said that, if we remember the equation on Px plus S0, when the Px differs, the approaches also, of course, should differ. And I put in a little citation there of, and that is that we've succeeded in categorizing insects and plants and so on, but still categorization of industrial energy end use, which is, in my view, far less complex in nature, this is still unexplored by us. And in order to have to make an improvement in this regard, there should be a general taxonomy developed that could be applicable for industrial SMEs. And since there is a lack of this one, we cannot compare data between countries and not even between regions, because the energy audits in one part of the country, they categorize one way, and auditors in another part of the country in another audit program, they categorize in another way. And so for today, I just want to emphasize that we need to develop a taxonomy in the future of how to categorize data. And because this data is lacking today, we have little knowledge actually of how much energy that is used for industrial SMEs, for the production process, and for the support process. And this means also, and if you remember my first slide there on potentials, we cannot really say how high the potential is, because we're lacking energy end use data, and we're actually also lacking implementation levels for various type of technologies. And this, of course, if you agree with me, we need to make a change in this regard. So let's aim for that in the future. So if we proceed on energy management, we can say that traditionally it has received low focus because of low non-variable energy prices, and also that energy cost is in fact a quite small portion of the total cost for an SME. But today we have increased priority thanks to rising prices, even though that might not hold right now. We've seen historically rising prices, also increased environmental attention, and the adoption of public policy instruments, and also the new standards that now have risen, starting with Denmark, continuing with Sweden in the more than 10 years ago. We now have an international standard, ISO 50001. And energy management is one of the foremost means to eliminate barriers to energy efficiency. And there is not so much research done in this regard. It's about 40 to 50 internationally published paper in this area. We have standards, as stated in my previous slide. But please note that without anchoring in the organization, a management system becomes quite ineffective. So I would like to emphasize that an energy management system is a tool for improved energy efficiency by leadership and energy management. So as an engineer, I often see this simplification that, yeah, but we have an energy management system. But this doesn't mean that we have a good, successful organization working with improved energy efficiency. This just means that we are certified. So please distinguish between an energy management system and successful energy management. And I will now just give you an overview of about 10 years of research, and this is definitely not any rocket science. So, but bear with me. It's very simple steps on important factors for successful energy management, and so not only energy management system implementation, but successful energy management in industrial SMEs. And it's a sample of about 250 case studies over, as I said, about 10 years. And first, we need to conduct an energy audit. And if we haven't done an energy audit, it's like for a controller to set a budget for the coming year without having any history of last year. It's basically impossible. In my own experience as an auditor is that when I go out to companies, they want to have measurements on the production equipment. But when we end up presenting the audit for industrial SMEs, we see that the major energy use is actually found in the support process. And this is not often the case, of course, because we can have the PX being very large. But it's very important to have an audit as the first important step. Then successful companies have the energy efficiency work anchored within top management. And also it's important to have a strategy with quantified goals of how much energy you would like to reduce or how much you would like to improve energy efficiency over the next 5 to 10 years. And this decision needs to be taken also at management level. So you have the top management commitment there. And then having an action plan on how to set objectives. And successful companies often have a long-term action plan, several years, and a short-term, which is maybe 1 year or so. And then that we have a position that takes charge of the energy efficiency issue, a clear owner of the energy efficiency issue, an energy controller. And this does not mean that, because for most industrial SMEs, it's way too costly to have a full-time energy controller. But to have to put an owner on the issue, that's what I mean here. That someone needs to carry this responsibility. And then it's important to set up sub-metering preferably at division level. And if you remember my example there of you being the CEO and I was the division manager, it's very important to have the allocation of energy cost based on sub-metering and not only on square meters for your division or number of employees for your division. Because in that case, the only way, if I'm a division manager, the only way for me to save energy cost is either to reduce my square meters I use or fire people to reduce my energy bill, which, yeah, I don't have to say anything else. It's just basically not a good idea. And then we've seen that successful companies also have established personnel responsible for the issue at each shift. And this means that we create the momentum in the issue. So when you have a shutdown of production, this person can make a phone call to the energy controller saying, you can please shut off the ventilation now for 4 hours. We don't need 100,000 square meters of air per hour for the ventilation. We can reduce that to a minimum. And then ongoing training is also important. Preferably, we start with some of the key persons in the company, and then we continue, if needed, for the whole industrial SME. And then it's also important to visualize the work. I have one example from the real world. My apologies here for all the men who is listening, but there was a few old guys in a company for the melting division, and they didn't shut off the melting and holding furnaces. So the energy manager, he was quite upset, but they didn't listen to him. So he started to visualize the work on the intranet. And if you know energy efficiency energy use divided by ton of melted metal, this means that the bar is infinite in July when we have vacation in Sweden. So by visualizing this, the energy manager succeeded on the 3rd year to convince these guys that they should shut off the holding and melting furnaces when they went on vacation. So this can be a good trick when we have the inertia, as we spoke of previously, the inertia barrier in the organization. And also establish an energy competition between departments has also been seen as and stated as a successful means. So why energy management? Well, if we look on the history of improved energy efficiency, we primarily tend to emphasize on the change of technology. But energy use is power multiplied by time. So the time variable is also an important variable when it comes to improved energy efficiency. So if we look on this figure, there is actually a higher potential if we include the potential for the employees to start working actively, efficiently, set up routines for operation of equipment, etc., and not only replacing the equipment and making investments in energy efficient technologies. So, going down into my the fourth part of my webinar is energy efficiency programs for SMEs. And this figure originates from a report by it was called Audit 2 from 2003, and Heikki Väisänen from Finland was coordinating that. And we have a number of important components when we go and set up an energy policy program for SMEs. We need to set program goals. How many SMEs do we want to reach in a 4 or 5 year period? How much improved energy efficiency do we want to see? Then we need to take care of the laws, and so on, that framework. What type of subsidy should we have? And also how should we promote and market this policy towards the SMEs? Then we have the structure of administration. What are the key players? What energy audit models are we using? We have, for example, if you look on the standards, and I think that originates from the ASHRAE, is the categorization of level 1, level 2, and level 3 audits, depending on the depth of the audit. Then we have the monitoring system. How we'll do the follow-up of our policy. Then we have the training of auditors, which is of key importance. Then we have the authorization. How will we authorize the auditors in the policy program? Then we have quality control, and then we have various tools for auditing, such as database, etc. So, successful programs, questions you need to ask yourself is, should we have fully or partly subsidized energy audits in the program? This question partly is answered by if you're within a European country, we have some rules and regulations from the European Commission. But it's an important question to ask in the setup of the program. And then the scope. Should we have the depth or should we have a level 1, level 2, level 3 audits? That's also important to ask in the setup. And then what type of sectors will we target? There is not, if you would have asked me a few years ago, I would have said that the cost effectiveness for industrial SMEs is a lot higher for energy audits than for the service sector. But we have seen in later research that it tends to be more related to the actual energy use than if it's the industrial sector or the service SME sector. And then, of course, the question, should we have an energy audit program for the SMEs, or should we have a long-term agreement or a voluntary agreement? And then the choice of operating agent and the local authority involvement. How can we anchor the program with the local authorities? Like in Sweden, we have municipality energy consultants that provide advice to consumers. That's one way of involving those in the program. And then evaluation. I cannot emphasize this enough. Think of the evaluation before you start the program. Otherwise, it is much more difficult to succeed in the evaluation. And sometimes, in a paper from the Australian energy audit program, it is stated in a paper by from Australia that before the program was evaluated, it was known as a failure. But after the evaluation, it was shown that it was a great success. So evaluation is important, and please think of that before you start the policy. Just a little reminder, the success factors for energy management. And then just a few examples of important driving forces where we asked industrial SMEs about important driving forces. And they state all people with real ambition and cost reductions are important driving forces. But few SMEs have successful energy management system approaches. And here we have a great challenge for government, etc. And that is to approach an actor which is sometimes both the production manager and the CEO and the his or her everyday life is quite the avalanche. And we don't know 3 weeks from now if we will have the order accepted and we can proceed, or otherwise we have to fire personnel in 3 months, etc. So the stability of an SME manager environment can be quite hard sometimes. And also, what technologies are we targeting? We mentioned about the PX, the share of production process in an industrial SME. Here is a summary of the length of the bar is the total number of suggested measures for that type of process, and the gray bar is the planned investments, and the black one was the investments they actually undertook. And we can see here that we have space heating and ventilation are the foremost undertaken measures. And we can also see that for production process, it is not that high. So when we set up an energy policy program for industrial SMEs, the knowledge that we have right now is that we are primarily targeting support processes. However, this figure can contain a bias. I just need to mention that, and that is that we as auditors are not often experts in the production process, which means that we will propose less sound measures for that production process. As an auditor, you're often experts in the support process, etc. And this can be this needs to be mentioned also. So in summary, yes, production process audits can also be important, but for SMEs, please start to look on the support processes. So, I will not give you an exam after the webinar about this figure, but we can see here that if we have the potential for energy efficiency, if we look only on technology, is in the middle here of the figure. And if we go up a little bit, we can see that the potential for management, including technology, is higher. And if we would have a total plan economy on in for example the EU, we could force every company to implement the best available technologies in any case without taking into consideration the cost, etc. And we could actually basically close, I would say, but near to close the energy efficiency potential for technology. But when it comes to management, we have a constitution in most countries in the world where we have some sort of market economy. And this means that we have given and provided power and authority for the companies to themselves operate and work with, for example, improved energy efficiency, setting a strategy, etc. This means that the potential for policy when it comes to also involving energy management components is actually not as high as the level of deployment, is not, or the potential, is not as high when it comes to policy than for that we have for both technology and management. And that is because we cannot force the companies to do measures because we have a constitution that we give them freedom to do so or not do so. So some successful type of policies, informative policies forms the backbone often in various countries for industrial SMEs, and that holds in particular to energy audit programs. Here's a little example of how we can look on the medium-sized companies and the energy-intensive companies and the small and the non-energy intensive. The amount of energy used for the medium-sized and energy-intensive is medium high. The human resources are limited, but they often have a few good engineers. And the production and support process are emphasized. While if we look for small-sized and non-energy intensive industrial SMEs, the share of energy use is small. They have very limited human resource for energy management, and the type of technology regarded is often support processes. Administrative policies for SMEs is, and I'm just saying now the knowledge I have, and that is based on the research in this area. So this is not like I provide you the full answer to this, but based on the current scientific knowledge, we can see that law enforcement is a good policy for medium-sized enterprises. And that is based on the Japanese experience with the energy conservation law. And in regard to policies, for example, in Belgium and Spain and Japan and Sweden, the governmental officials that are to enforce the law are sometimes not as experienced in the energy efficiency issue, and this is a problem with this type of policy. Then we have the economic policies, which can be any of the program subsidies, and it can be voluntary agreements or long-term agreements. We have a tax deduction, and those are often merged with informative policies. And the level of subsidy, again, it has large implications also on the cost effectiveness of the policy. There is very little research on adequate levels of how much we should subsidize an audit in order to have success. And also, we see that applying for funding for SMEs should be extremely easy because they don't have time to do this. And I just have, this is results from the International Energy Agency's project that I was involved in, where we studied successful policies for SMEs. And for medium-sized and energy-intensive SMEs, we proposed law enforcement, audit programs, energy efficiency networks, for investment subsidies, benchmarking, and sector guidelines. And for the small and non-energy intensive, we proposed audit programs, energy efficiency networks, investment subsidies, benchmarking, and sector guidelines. That was our expert input to policymakers in regard to improved energy efficiency in SMEs. So if we try and make a little soft landing here, we can say that overall energy use is lower for industrial SMEs than for the energy-intensive industry in the country. And that is probably one reason why there historically has been a scarcity of policies towards industrial SMEs. But as we saw in one of the first slides here, the high impact on GDP from SMEs in the country and the high cost effectiveness of energy efficiency policies, primarily energy audit programs for SMEs, calls for focus also on this sector. And if we only look on the availability of low-cost potentials of energy efficiency measures on the market, the deployable energy efficiency potential among SMEs can in fact be high, because the cost for finding these levels in energy-intensive process industry is more difficult. And so the goal or the aim of a policy for SMEs could not only be to save energy or improve energy efficiency, but equally or perhaps more important is to support these firms in the long-term survival and success. And I'm speaking here for a nation as such, or a region as EU as such, how we can look on the energy efficiency issue in SMEs. And also guidelines or standard procedures on how to evaluate energy use policies is also of importance. And also, as stated in my webinar, to also categorize processes based on a typical categorization. So I wrote the book together with a social scientist, Professor Jenny Palm, a few years ago, and we mentioned something about transaction analysis. And some of you probably have heard about it. It originates from Eric Berne and his work from 1963. And what I want to say just briefly about this in my ending remark is that in this theory, it regards relationship. You can take three roles. So in a relationship between you and me, I can look on myself as an adult, and I can look on you as an adult, and also parent and child. This means we have 6 types of relationships that we can enter. And of course, the desired outcome is to have an adult-adult relationship where we can communicate without being angry with each other and without controlling each other, etc. And if we are to boost the EU energy efficiency potential through the Energy Efficiency Directive, this means we have to move from a parent-to-child relationship to a more adult-to-adult relationship between the government and industry. And we just published a paper with 2 of my colleagues and friends from Japan on this regard, and we can see that in Japan, they both have the law enforcement, which could be seen as a parent-to-child, but they also have the world's largest voluntary agreement, which is more an adult-to-adult. So it doesn't mean that you only have to have adult-to-adult, but in order to succeed, both the industry and the government need to take responsibility.